Solving inequalities. Last section was solving equations. This section, solving inequalities. Hopefully you remember what the inequalities are. There's only a couple of different rules that we have to talk about. I want to review what the meaning of the symbols are, and then pretty much we'll do a couple problems, and that's it. So here we go. What is that symbol? It means less than. So an example of that would be like 4 is less than 6, right? Make sure you're reading that correctly. We need to get beyond the elementary or middle school. The alligator eats the larger thing. The reason we have to do that is because we're going to be doing things with greater than and less than, where you need to understand what the symbol is actually saying, not the little trick to remember which way it points, okay? You need to read this as 4 is less than 6, which means that this thing over here is smaller than this thing over here, okay? The graph of less than, if I have a number line and I have maybe 4 sitting right here, less than would be, I need a dot and I need a direction for a line. Where am I going? What's my dot? The dot is open. And I go up and that way. Which way is that way? Left. Good. In the back of the book, if you were to look at that as an answer, they would show the open dot and then they would shade. We are not shading because shading is messy and it takes longer. Do it this way. We'll all understand what that means. And then you can move on to the next problem faster. All right, what is the next symbol? Good. Less than or equal to. So for example, could I say 3 is less than or equal to 5? Would that be true? Yes. Could I say 3 is less than or equal to 3? Is that true? Yes. If I were to graph less than or equal to, let me put, let's say, 3 here. Less than or equal to means what? Closed dot. And to the left. So now we know the difference between open dot and closed dot. All right, what's the next symbol? Yes, more than, but we usually say greater than. For example, 6 is greater than 4. True? Okay. And let me put a number line down here. I'll put a number in the middle. We'll call it 5. And I want greater than. So that means I need what? Open dot. Up to the right.
When you use, like the only time you use closed dot is when it has the line under it.
That's right. If it says or equal to, you're going to use a closed dot. If it doesn't say that, then you're going to use an open dot. And all we're saying is you can be exactly 3 here, but here you can't be exactly 4. That's our notation for can't be exactly that, but we can be exactly that. Okay? Finally, the last one. Good? Greater than or equal to. So for example, I could have 3 is greater than or equal to 2. I could have 3 is greater than or equal to 3. Both of those are true. If I'm going to graph this guy, my number line, and let me put 6 on here this time just for something different. What do I do?
Closed dot.
Closed dot this time, good. And
To the right.
up and to the right for greater than, because those are the numbers that are bigger than 6. For the most part, solving equations and solving inequalities are the same thing, with the exception of one major difference. What is that major difference? No. You still have variables, you still have numbers. What about it? What's the major difference? There's something that happens as you're solving these things. Something happens there, yeah. Has to do with negatives. So everything is the same except what? I bet Mrs. Robertson knows. Except when? What? Something happens to make the symbol flip. Multiplication or division by? Except when multiplying or dividing by a negative. The symbol. A sign is like a positive or negative. A symbol is like greater than or less than. Okay? When that happens, when you multiply or divide by a negative, the symbol flips. If it was greater than, it's now less than. If it was less than or equal to, it's now greater than. That is the important distinction between inequalities and equations. You have to remember that rule. Questions on that? All right, let's take a look at the first one then. I'll work through this one, and then we'll work together on the other three. I see this situation happening here, which is leading me to think I need to do what first? It leads me to think I need to distribute first. So I'm going to. I get negative 6x, what? Plus 15 plus 1 is greater than or equal to 4. I didn't multiply both sides by a negative number, so the symbol stays the same. I did distribute a negative number here, but it wasn't multiplying or dividing both sides by a negative number. So in my definition, everything is the same except when multiplying or dividing. Let me put both sides here. If you're using the properties of equality, multiplying both sides by a number, and that number happens to be negative, then you're going to flip the symbol. So I'm not flipping the symbol here. Now what do? After I distribute, I combine like terms. I have like terms right here, so I have negative 6x plus 16. Good? And then we just continue, just like solving equations. So subtract 16 from both sides. And now I have negative 6x is greater than or equal to negative 12. It's treated like an equal sign. Yeah, the equal sign, the greater than or less than symbols, those are all symbols that represent the other side of what we're looking at, whether it's an equality, an inequality, or an equation. Okay? Divide by what? Negative 6 on each side. So now I wind up with x. Wow. I wind up with x on the left. What do I wind up with on the right? Positive 2. And what is my symbol? Good. Why did it flip? Because we divided by a negative 6. Now, check your answer. You can check your answer very easily with these problems. Pick a number that meets this criteria. Pick a number that's less than or equal to 2. Pick an easier number than 2. Pick an easier number than 1. 0. Plug 0 in here and you get negative 5 times negative 3, which is 15, plus 1 is that greater than or equal to 4? Seems like we did the problem right. Okay? It's easy to check these. Talk me through the second one. Okay, I heard distribute, so what do we get? Good. Minus 18. Yep. Three. The symbol did not flip because we did not multiply both sides by a negative number. We just distributed a negative number. Okay, now what? Combine like terms, so we have what? Negative 2x. Good. Greater than or equal to 3. Now what? Okay, add 13 to both sides. And we have, yep, greater than or equal to 16. Now what? Divide by negative 2 to both sides. X is, good, flip the symbol, less than or equal to? Negative 8. All right, so that's the idea. Check it to make sure that it works. Pick a number that's less than or equal to negative 8. What do we have? What's a good number? Is 0 less than or equal to negative 8? No, it's not. So like negative 10 maybe? Just trying to pick an easy number to work with. Negative 10 plus 9 is? Negative 1 times negative 2 is? Plus 5 is? Did we get a true statement? 7 is greater than or equal to 3, right? So that is the true statement. So it seems like this works. Now, what have we not done? Okay. What we have not done is graphed. So we need a graph. I don't have a whole lot of room up here. Hopefully you guys have more room than I do. But I'm going to put my graph right here for the first problem. I need to come up with a number line. I have a 2 sitting right here, so let's put 2 right in the middle. And then maybe I can put 1 over here and 3 over here. That's a good enough number line for me. I have to graph this though, so that means I need a dot and some sort of shading. The dot will be, it's less than or equal to means closed. Because I can actually be at 2. Closed means I can be there. And then less than tells me which way. Left. So I go like that. That's my graph. Takes an extra 10 seconds. So don't forget to put it on there. Okay, other graph. What do I do? Good. We put negative 8 in the middle, and I need a number to the left of that, a number smaller than negative 8, which is negative 9. And then on this side, negative 7. Be very careful with those negatives. Okay, now what? Close dot and left. There you go. All right, let's do the other two. Go for it. All right, what do we do? First one on the left. Distribute, so we get, yeah. Okay. Does anybody have any little alarms going off in their head? Maybe an annoying ringing sound? Yeah? All right, so. And we're saying that the x's now disappear, so I'm left with negative 2 is greater than positive 7. Wow, look at that, 77 sitting there. Greater than positive 7. False. What if I what?
Added 2 the other side.
Yeah? You'll wind up eventually with the same thing. You'll have different numbers, but right here, you can see that this is false, right? If you wind up with something different, can you see that what you wound up with is false? Yes. So since this is false, that means it's never true. No solution. And if there's no solution, then the number line would not have any shading on it at all. It's just going to be a number line. You don't even have to draw it. It's just no solution. Second one, what do we do? Okay, distribute. What do we got? 8x minus 12. Yeah. Plus 8. Okay, now what? After you get over the bells going off in your head, we're going to do what? Subtract the 8x. And this makes it obvious. We're left with negative 12 is less than positive 8. True? Yes, that is true. Negative 12 is less than positive 8, always. So therefore, the solution here is all real numbers. If you look in the back of the book, they're going to give you a number line, and they're going to shade the whole thing. You give me all real numbers, I'm going to be happy with that. Show me the graph, fine. Okay? Here we go. Story problem time. A digital music service offers 2 subscription plans. The first has a membership fee and charges that. The second has a different membership fee and charges that. How many songs must you download to make the second plan worth it? The reason I'm asking that is, right off the bat, which plan is better? The first one, because you're paying less immediately, right? But eventually, because of this $1 fee per download and this 50-cent fee per download for the second plan, eventually the second plan will take over, right? So we need to figure out when that happens. We've talked about this. What do we need to do? Define a variable. So, okay, D equals downloads, nice. And I'd go even further and say the number of downloads, not hashtag of downloads. Now what? Okay, so I need to know what I'm talking about, right? So I'm going to go first plan, and then I'm going to write that expression. What is the first plan's expression going to be? Yes, right off the bat, I'm hit with 9 plus $1 per download, so 1D or just D. Okay, is that it? That's it. Second plan. Hit with $25 fee immediately. Plus 0.5D. Now, since we're in the inequality section, we should probably come up with an inequality. We want to find out when this costs more or costs less than this. We want this to cost less than this. So we are going to say 25 plus 0.5D is less than or equal to 9 plus D. That's how you set this one up. From here, then, you solve. I'm going to subtract 0.5D from both sides. We have 25 less than or equal to 9 plus 0.5D. You could switch that to a fraction. In fact, I would have already, but if you don't, that's okay. That would be what fraction? 1/2. 1/2 is easier to work with than 0.5. Okay, now we're going to subtract 9 from both sides, and this becomes 25 minus 9, 16, less than or equal to, I'm going to switch that to 1/2 D. The reason I'm switching it to 1/2 is because now I can clearly see that if I multiply by 2, I can get rid of that 1/2. And that becomes 32 is less than or equal to D. In other words, D is what compared to 32? D is greater than or equal to 32. So if you want to write it with the variable out front, remember that you're reading backwards what your answer said. This said 32 is less than or equal to D. If I read this backwards, then it says D is greater than or equal to 32. And that's what I wrote right there. So 32 what? Turtles. Downloads. So if you're going to download 32 songs or more, plan 2 is for you. If not, go with plan 1.